Hello, hello. How are you doing? I'm finally doing another live stream. It's been a long time since I did the last one. Let me know if there's any problems with the audio, if you can hear me all right. Yeah, so the topic for today's video is gonna be, we're gonna continue from where we left off. Oh, you have an exam tomorrow. Okay. Good luck with your exam. Okay, so the plan for today is we're gonna continue from where we left off with the C++ migration, but before doing that, there are some issues that I've noticed, one of them being the issue with libguestfs. If you are unaware, okay, let me just show you. So as part of the process of creating the disk image, I'm using libguestfs, which is great because it allows us to mount things without having root access, without needing sudo. Unfortunately, this doesn't work for everyone, and I've noticed this problem myself when working with in Windows subsystem from Linux, and I'm also pretty sure it doesn't work on Mac OS. So I'd like to start by trying to address this problem and adding a different mount method to our code. So let's go ahead and begin doing that. First, let's go and add another configuration option here, and let's just call it mount method. And by default, let's set this to I don't know, it doesn't really matter. I'm gonna set it to guestfs. Just writing a little comment here. So guestfs, this uses libguestfs. Doesn't require admin rights, but may not work on some systems. And then we have mount, which uses mount and requires sudo. All right, so because we are working on this mount method, I'm gonna set this default to mount, but when I'm gonna commit, I'm gonna set it back to guestfs. Okay. Next, the next thing we need to do. Okay, so yeah, now let's use this mount method, and the main place where I am creating this image is in this image scan script, and we're gonna start here. Okay, let me see where we are using guestfs. So the main place where we have this problem is in one of these. Okay, here, where we do mountfs. So let's go to this mountfs function and see how we can fix it and make it work with either the guest mount method or the mount method. All right, let's see. Okay, so let's add another parameter here for the mount method. And if mount method is guestfs, then we do what we've done in the past. We are also gonna return something from this function because you'll see in just a moment why. Okay, so let's do else if mount method is mount, then okay, so first we need to solve the problem. We need to get the sudo password. Using sudo from a command from a script is a bit more tricky, so this is kind of what I'm trying to do here. So first, let's try to get this password. We're gonna write the function get sudo word. We are also going to want to cache this because we are going to run multiple commands, and we don't want to ask the user like 4 times the password. 1 time is enough. So we're going to cache the password. Okay, so get sudo password, and as parameter, let's have like a prompt that will be shown to the user. Please type your username password for running mount. Okay, and once we get the password, so this sh library, it has something. I've done some research before, so this is how I know this. I've already done some research on how to do this, and I've tried it, and I know it works. So it took me a while to figure it out. So this is why I try to prepare when I do these kind of live things, because debugging stuff live takes a lot of time, and you're probably already familiar with that. So I'm trying to make this a little bit faster, this process. Okay, so let's go and learn about this sh library Python. And let's try to find the documentation. This is the library we're using to run commands using Python. It's really convenient because instead of using sub process, it's a lot faster. We don't have to type that much stuff, and it handles a lot of stuff for us. So for example, if I want to run ls, instead of trying to do the sub process stuff, all that stuff, all I have to do is simply call sh.ls, which is the command, and then pass the list of parameters as a list, as each argument is a different parameter. And we can also have named parameters. This will be translated into -- color equals never. And there are also some other options like exit codes can be quotes using exceptions. It also handles redirection really well, and it does a lot of things really interestingly. Now, here in the documentation, there's this section on using sudo. And this is an interesting concept. So basically the way it works, you use this with, which is basically using with resources, similar to the try in Java or using in C#. So we're using this sudo, and now everything that's inside this block is gonna have that elevated access. However, as you can see, apparently this should automatically ask for password using the getPass method, but from my experience, it didn't work very well. So this is why I'm gonna implement my own getPassword. Okay, so I go to the password, and now we're gonna do with sh.contrib.sudo, and we're gonna set the password argument, and then we have 2 more things, k equal true and with equal true. Now these 2, I've also noticed. Let me see if I can find them. Okay, so k equals true, that's a sudo argument. So if I run sudo help -k is invalidate timestamp file. Okay, so there's that. I've had issues when running sudo. It didn't work properly. It didn't ask for password properly if I didn't pass this. It also has the password argument, so if I go back to the terminal, I think it has a password. Okay, I don't see it, but I remember it having. Okay, so this one might be handled by this library, this sh library. I was thinking that maybe it has like a -- password argument, but I don't see it. Okay, and with equals true, this is basically gonna tell sh that we are using this in a with context, because I noticed that sometimes this doesn't work properly if I don't do this. Okay, so now we have admin rights inside this with block. So let's do what we need to do. And the first thing is we cannot mount this image directly because this image, it might have partitions, and you cannot mount in order to set up in order to mount a partition from inside a disk image, we first need to attach it, which is done using lo setup. I think on macOS it's hd attach or something like that. It's a different command. I don't support macOS yet in this build system, but yeah, if you are using macOS, then you might be familiar. You might need to use that. Let's see, hd attach. I think it was the command. No, it's not hd attach. It's something similar. Let me just look it up. HDI util attach. Okay, so this was the command. HDI util attach. And I think BSD based operating systems like FreeBSD also do the same thing. Okay, so yeah, if you're using a Mac, you might want to use this instead. Okay, so let's call sh.lo setup, and then we want to see which arguments. So let's see, lo setup help. Okay, so since we want to attach a disk, where is it? So -d is for detach, but for attach, okay, so we're just okay, we want to have this partition scan. That's one thing. Find first unused device. Yes, this is a very useful method because, for example, on Ubuntu, if you go to ls/dev/loop and everything there, I only have one loop device attached. But on Ubuntu, where you have snaps, snaps tend to use a lot of these loop devices. So this is a very good idea to use this find, which is gonna basically find a loop device automatically. Then print device name after setup. This is also something we need. It's simply gonna print the device that it picked when using find. Okay, and let's see what else. Yeah, basically that's it. So these are the arguments. And to attach, all I have to do is simply type the disk image name here. We can actually try this to see how it works. So let's do that. Sudo lo setup, and we want to pass the okay, so let's see what options I said. Find, so -f, and part scan, so -P, and then show, so --show. And now we pass the name of the image, which should be in build. Debug, let's just use image.img, whatever that is. And okay, so it attached it to dev loop 0. And now to detach, we're gonna do the same thing, but instead, now we have to use this name instead. So we cannot use the image name. So lo setup -d, and then type in this dev loop 0, and now it is detached. Okay, so now let's see how we can implement this here into this script. Okay, now for the script, I'm going to use the long names for the arguments because it makes it a lot clearer what it means. k equals true, for example, is not very meaningful. But if I use the full name of the option, it's going to be a lot more meaningful when reading the code. Okay, so we want to mount the image. And then we're going to pass the parameters. Partition scan was called part scan, so part scan equals true. Find equals true. And then show equals true. So now we have all the arguments. Okay, now we want to capture the output of this command, and to do that, we're gonna use tty in equals true. I think it's just one, and then unify tti's equals true. I'm gonna show you what this means in just a second. So something about using this tool. Let's see. So these are some special arguments. Tty in means that it's gonna create a tty for standard input, as if this command was typed from the command line. There's a bit of a difference on how these are handled. So basically, you can capture the output from... Okay, so here you go. You can basically... For example, if you use the Docker command, you know that Docker has an option to use a TTI or not use a TTI. So okay, I don't see it. I think it was Docker run. And let's grep for tty. Okay, and allocate a sudo tty. Some commands are a bit don't work very well if you simply capture if you simply use a pipe to capture the output or for the input, and using a TTI solves that problem. TTI is essentially like creating a virtual terminal, specifically for some programs that manipulate the TTY. For example, the Vim, for example, it manipulates the terminal device. It basically expects that this is the device that has a specific width and a specific height, and it kind of manipulates how everything works in that environment. If you simply pipe this to a non-terminal, so you simply pipe this to a file, then it's not going to work very well because that's not what it expects. So this is why some commands require a TTY to work properly. Also, less is another one that does the same thing. It manipulates the TTY. If I resize this window, you can see that it automatically changes based on the window size. So it also manipulates the terminal window itself. Some commands are not very happy about if they don't have this virtual terminal. So this is why some commands require that TTY. Okay, and this is basically just trial and error. So I tried to use it without the TTY, but it didn't work properly. It didn't output stuff correctly. So this is how I found out that I need to use this TTY in. And this unify TTYs, it's gonna combine the std out and the std in a single terminal. All right, let's get back to our code. Okay, so this is gonna output the name of the device that it picked. So let's call that out. And now we're gonna parse the output of this command. So let's just split it by the end of the line, And if there's a dev inside this line, then that line contains our loop device. So loop device equals line.strip. So we're gonna just strip all the spaces and anything else like that. Okay. And finally, we want to mount this device. So sh.mount. Now, something that's gonna happen when we do this LO setup, and I'll do this again to show you. And if I show the list of devices under dev loop, you can see that we have this loop 0p1, which is the first partition for this dev loop device. And we can also use fdisk to show the partitions of the loop 0 device. And you can see there's a single partition starting at this offset, ending at this offset, and so on. So yeah. Okay, now let's detach it. Okay, so we're gonna mount this loop device, and we have this mount directory. This is where we want to do the mount. So we're gonna mount the device loop device plus p1 because that's the name that that the operating system basically assigned to it. Mount directory, and then we want an option to set, which is the user ID. We want to be able to access these files without root. We want to be able to copy files without requiring this sudo access. So we're gonna use UID equals the UID of the current user that we need to read. So after getting this password, let's also get the user ID, which can be done from os.getUID. Okay, so now we should have the mount handled. Now let's take care of unmount. Same as before, we also need to have the mount method. Oh, okay, so I forgot one thing here. If the mount method is neither guestfs or mount, we're just gonna throw an exception. Unknown mount method. Okay, that looks much better. And we're also going to need one more thing to do here in this mount function. We need to somehow take this loop device and send it to the unmount function. So we're just gonna return it here after handling this. Return loop device. Okay, and we're gonna return null from here. So return none. Okay, back to unmount. So we're also gonna have, let's just call it mount token. Okay, so if the mount method is what did I call it, guestfs, then we're just gonna do what we did previously. Else we want to do the same. We want to get the sudo password, but this time we should probably have it cached, so this is not gonna ask the user again. Then we also gonna have this with, and let's do sh.unmount, so umount the mount directory. This is how we can unmount. And then we also want to detach it using LO setup. All right, this should take care of that. Yeah, that's basically it. And I also added a little sleep here. And the reason why I added this sleep is because it takes like this LO setup is not done synchronously, so you might get some errors that you cannot access the image file, for example, right after this LO setup is done, which is why we give it a little time to do whatever it needs to do. Okay, now let's see how where this function is called. So let's go to build disk. Okay, here is where I basically take the arguments from the scorns environment. So we're gonna have to do the same with the mount method. So mount method equals env of mount method. Okay, and now let's go to where we mount, and here we need to basically take that mount token, and we also need to pass the mount method. Okay, and now in this finally, where we unmount, we also need to pass this mount token. Let me see if everything looks right. Okay, so there's one more thing that we need to do here. We need to create that get sudo password method. Let's see where I used it. Okay, and let's create a function, get sudo password. Okay, now Python has this function which is called getPass, which is the way you want to get passwords, because it's not gonna echo the password to the user, so this is the safe way of getting the password basically. Okay, so let's import whatever we need for this. And I'm gonna add a variable here, cached sudo password, and initially we don't have anything cached here. And now inside this get sudo password, we can write a little documentation. So uses get pass to read a password from the user. So we only need to request once. And first, we're gonna tell Python that we want to use the cached sudo password global variable. Otherwise, it's just gonna create a local variable called cached sudo password, which we don't want. So if this is none, then we're just gonna set it to get pass of the prompt given by the user. And then we're gonna return the cached password. Okay, so I think we're pretty much done here. Let's test it and see if it works. So inside config, we have set the mount method to mount, and let's see if this is going to work. Let's just force some change. So let's do a scones clean. I think it was -c. Okay, yeah, it's scones -c to clean. And now let's build. Okay, so we are having a little problem here. Okay, so I forgot to add this to one other place, which is in the mains construct file. Here we have all the variables that can be passed from the user basically, and we also need to add this enum variable mount method. And we can just copy from here. The default, let's just use guestfs, and allowed values are guestfs and mount. Okay, let's try again. Okay, and now it's asking me for a password, so let me type in my password. Okay, so I got this device or resource busy. I wonder where this error is coming from. Let's see what happened. Let's see if we have the image anywhere. Okay, so the device is still attached. So it looks like device or resource busy. I wonder where that is coming from. So it mounted the image successfully, it copied all the files, and during cleanup. Okay, so let's see what happened during cleanup. Okay, so this is where we do the cleanup. Okay, so it's definitely something that happened during unmounting. Maybe we need to add a sleep in between these two. Let's see. Did it unmount it? Okay, so it looks like it didn't unmount anything. The image is still mounted. Okay. I don't know why the middle click isn't working. Okay. And now I'm gonna do this manually. Low setup -d dev loop 0. All right. Okay. Not really sure what the problem is here. So it looks like the unmount itself is where the error occurred. Let's see. Let's do a bit of research. What I'm thinking is happening is that I copied the files, but they weren't written to the disk immediately. It's taking a while for them to be written to the disk. I think that's what is happening. And I think the solution might be to use some mounting option. Maybe sync. Okay, so all changes are immediately flushed to the disk. So yeah, I think this is the one we need. Okay, so let me try to add this. Okay, so we've set the user ID and let's also set sync. And let's try again. Okay. Still device to resource busy. That's odd. But you know what's odd? Because I didn't notice this sleep. Why is it not sleeping? Let's increase the sleep, I guess. Okay, that's a bit odd. I don't know, let's set this to 10, but this is weird. It's not sleeping. You can see that, you can see right here. Why is sleep not working? This is very odd. This is very odd. I don't understand why this is not working. So I'm asking it to sleep for 5 seconds. So, and this is seconds, it's not milliseconds. Let's set it to something crazy, like 50 seconds. It should not sleep for... It should sleep for 50 seconds. It's not sleeping. I think that's very strange. Is it something related to this thing? I don't know. This is very strange. In theory, this should work. I've tested it before and it worked. I'm not really sure why this sleep is behaving like this. It's weird. Anyway. Okay, this should solve the problem. So, yeah, let's commit these changes. Let's also take this moment to fix another issue that I've noticed pretty frequently. Inside this setup toolchain, it's not creating the directory and it's giving errors to some people. So let's just fix this really quickly. Okay. Yeah, let's commit these changes. So this, and this. Okay. Commit and push. Where is push? Here is push. Okay. So yeah, let's see questions. If you have any questions, somebody wants to offer me a job. Nah, cool. What can I say? I was on your server, but some people demotivated me by saying I don't have enough experience in coding. Okay. Yeah, this is a bit hard to say, but to making an operating system is not exactly an easy task, but you can absolutely learn a lot from doing it. So I encourage you to keep going and keep trying. What I would recommend most people to do is, because some of the stuff that we do here is pretty advanced, such as manipulating the stack or, doing all that assembly stuff. So there's a lot of stuff that can be pretty difficult to do. And what I generally recommend people is to start off with something they're comfortable with and something that they can learn from. For example, you can start writing an operating system by, I don't know, trying to implement a file system. You can absolutely write a file system and, create your image files, then use the tools like makefs.fat, for example, to format these image files, and then you can try to create tools that work in Linux or Windows that can interact with these image files. You can absolutely do that, and you don't need to write a kernel to do that. You can do that from Windows. And there are a lot of little projects that you can do to learn operating system stuff without actually writing a kernel. You can do the same to write a memory manager. You can simply simulate that, and I've actually done this in my latest 2 videos about memory management techniques. This is exactly what I did. I implemented them as applications that run on Linux and that I could test properly, I could interact with properly. Because when you are in a kernel environment and when you are in this virtual machine environment, debugging gets a lot more difficult. So yeah, this is something that I always recommend people to do. And you can absolutely learn a lot from doing that. And by doing these little projects, you're, on one hand, you are working on your OS, you're making progress towards creating your own operating system, and you're also learning how to program, you're learning how to use all the tools like Makefile, Bash, and so on, all the tools that of the trade. You're learning how to use Git maybe. So there's a lot of value there, and there's a lot you can learn from it. And I strongly encourage people who aren't so good at programming, who don't have enough experience, to try to do these little projects and try to get better at programming. And when you feel comfortable making that jump and trying to write the kernel itself, then you can do that. Okay. Let's continue with the next thing that I want to do. So yeah, this was my first idea, my first thing that I wanted to work on. And the second one is, give me an idea on how to start learning on developing OS. Yeah, that's great. That's the way to do it. Develop small tools like, for example, reading a file system. And if you are interested in building a UI, then you can build a UI using, you can use, for example, SDL, or using some rendering library that can quickly get your pixels to the screen. So I think there's another one that I've also used, SFML. It's a C++ library, very easy to use. It's meant for 2D graphics, basically. It's meant for 2D games, but you can absolutely just use it to push pixels to the screen. And then once you have that, you just develop your own UI system. You know, you try to handle the mouse, the keyboard, and all that. You build your UI widgets, like the window, the buttons, and so on. That's also something you can do. But of course, once you feel comfortable with going low level, then you can go low level. There's a lot of learning to do, and there's a lot of... and something that I've noticed from my own experience is that having more experience coding and programming helps a tremendous amount. When I started trying to do this a long time ago, when I tried to write my first operating system, I was in 11th grade in high school, and it was quite difficult for me. There was a lot of things that I didn't understand. I did my best trying to understand how everything works, but it wasn't easy. And I enjoyed that. I learned a lot from that experience, but I also didn't get very far, unfortunately. And now when I'm approaching this from a different angle, I've been working in the industry for a few years, and I know how to look things up. I know how to find information. I think it's much easier. I'm finding it much more enjoyable and much easier to do the stuff. My only constraint is the limited time that I have, and also the fact that I'm making videos about everything that I do, which is why it's taking so long. This is why I've been developing this OS for years now. It's been like 4 years since my first upload. But yeah, beyond that, my biggest limitation right now is time. It's not skill. I'm not getting stuck on things that I can simply look up the documentation, see how that chip is working, see how, how Linux does it. This is another thing that was really difficult for me, because back then in 11th grade, when I tried to do this, I didn't know how to read code. I couldn't understand code. I was looking at the source code of various things, and it was very hard for me to understand what was happening in there. But after having all this experience, now looking up code, looking up how Linux does things, it's very easy for me. And I think it's more enjoyable. And as I said, my only constraint right now is the limited time that I have. I just don't have time to do all the things that I want to do. Yeah. But, yeah. I encourage everyone, and no matter what your skill level is, do projects and learn from it. You're gonna make mistakes, but you're gonna learn from them, and you're gonna get better at programming. For example, a classic example of a mistake that I did when I was at that age was trying to implement things that I didn't really need, but I thought were cool. For example, I started by creating an interpreter for my operating system inside the kernel. So I couldn't run programs inside my operating system, but I wanted to have an interpreter. That was important for me. So I spent a lot of time trying to parse strings and learning how to do that, trying to write that interpreter. Another thing that, yeah, so you can get stuck on when you don't have experience. Yeah, it's kind of hard to prioritize what you want to work on. Your priorities are out of order. You tend to work on things that you think are cool and interesting, and things that are difficult you kind of tend to put away. Multitasking is quite a difficult task. It's even looking in history, for example, the development of Mac OS Classic. They tried to do multitasking, preemptive multitasking, and they failed. It didn't work well for them. They had problems with it, and just ended up buying that time Next Step. And they used the Next Step operating system, which was obviously based on BSD. It was a fork of BSD. But yeah, some of these things is not easy. Getting things right is not easy. Fortunately, a big advantage that we have right now that they didn't have back then is we have a lot of operating systems that are already made. We have Linux, we have BSD, all the different BSD versions that are open source. We can look them up. We can see how they work, and we can also learn. There's a lot more information about how to do this kind of stuff. Back then, there wasn't that much information, you know, it's even hard for me to imagine having to program and having to look inside books, having to browse books, trying to find documentation on how some chip works or something else works. Having all this information online is a huge advantage that we have that those people didn't have back then. Okay, let's move on to the next topic. And the next topic that I want to cover is I want to refactor a bit. Maybe not refactor. Refactor maybe is not the right word. I want to work a bit on stage 1 and convert stage 2. Right now, stage 2 is a raw binary file. So it's a flat binary executable. And this is not very cool because we cannot debug it properly. We don't have symbols, so we cannot use, for example, Visual Studio Code to debug it. We cannot see the source code while debugging. We have to debug by looking at assembly code, which is not cool. It's not great. It's not nice. Okay, so let's see what we need to do in order to achieve that. We've already done it inside stage 2. It's a while ago. We haven't migrated this to C++ yet, but we have this elf.c implementation here. And the basic idea here is we're opening this elf file. It has a couple of headers. We are looking at these headers, validating the bitness, the endianness, and so on. We're validating that it's what we expect it to be. And then we look for the program header. Let me just show you inside this with the readelf. Okay, so if I use readelf, I think it's something like this. Build, and let's just take the kernel.elf. This is what the kernel looks like. This is basically the header. You can find the documentation for all the fields on OSDev or on Wikipedia. So this is just giving us a nicer look at what everything means. What we're looking for here is we want to go to the program headers, and there's an offset here somewhere. I can see it right now. Okay, so one thing that we need is this entry point address. This is going to tell us where to start executing. So where to jump whenever after we load this elf file into memory, we want to start executing it. And that entry point is right at this address. This is a useful piece of information that we're going to use. And then we need to go to the program headers, and there's some field that I don't see right here. Okay, start of program headers. There we go. Start of program headers, and we're gonna go to the program itself. And here is exactly, here it tells us exactly what we need to do. So we need to load into memory. It's expecting to have this virtual address. This is the offset in the file itself, in the elf file, where we can find this program. And this is the size. So what we need to do is load this from the file from offset from this offset, we need to read this number of bytes and place it into memory at this virtual address. Okay, now, how do we do that? The main issue here is that in stage 1 we have very limited space available. Trying to implement all this code in stage 1 is going to be pretty difficult, and we also don't have the luxury of writing it in C. We have to use assembly, which is even more fun. So how can we address this issue? Okay. How can we address this issue? We're gonna do a very... The way I thought about how to do this is to essentially simplify the process. So we're gonna take the brunt of all this implementation and we're gonna put it inside our code that creates the disk image, which is inside this script that we edited. It's this Python code basically, since it's Python. So inside image, where was it? Image script. Right here, we're gonna do that inside this install stage2 method. And what we're gonna do is we're gonna give stage 1 a very simplified list of what sectors it needs to read from the disk. This is the way I thought about this. Okay, just a second, let me look something up. Okay. Okay, so let's... Okay, there are some ideas in the comments. Okay, let's see them. Is there a reason to straight up load an elf? What about reading a plain binary with a simple header, which then calls into cmain, which loads the elf? We could do that, but that would essentially be like attaching some data before the elf file, and it's getting complicated. Having 3 stages, that's way too much. We can do it simpler. We can actually do things much simpler. And I've written a little readme file that describes how to do this. I'm just gonna copy it here, so, and then I'm gonna explain it. So okay, so the way I thought about this is like this. We're gonna create a config.inc file which contains the variables that we care about. We're gonna have stage 1 relocate itself. Now, I think at this moment it doesn't relocate itself. Okay, so let me just grab a text file here. So right now, stage 1 is loaded at 7C00. This is where stage 1 is located, and if I remember correctly, it loads stage 2 at the address 500. So this is a bit problematic because if stage 2 grows larger than the space between 500 and 7C00, then stage 1 would be overwritten and it's gonna create problems. So let's first relocate stage 1. This is the first step that I'm gonna take. And then we're gonna read one sector. We're gonna have Okay, then I've written here to read sector 1, which contains the boot table that describes how stage 2 should be loaded. Okay, the idea here is that we have the disk image. So let's say that we have stage 1, which is in the boot sector. Okay, and then we have more file system stuff, and then we have the data, the files themselves. So why not reserve the second sector of this disk and put a little table there. And the table that I was thinking about will have this format. So first it will contain the segment and offset of the entry point, which is basically the first thing that we need from that elf header. And then it's gonna have the boot table entries. And a boot table entries essentially contains a pair of three things. The sector from which to load that part of the... Okay, so for example, yeah, the sector where stage 2 is located essentially. This is the sector. Then this is where we want to load it into memory. And this is how many bytes, or how many sectors, in fact, it has. And then it's going to do a jump to that entry point address. Okay. Let's see. Let me check the chat. Okay, to create a binary file and an ELF file and then use the binary, then use the ELF for debugging. We could do that, but it's I'm not sure if it's gonna work very well. I'm not really certain if it's gonna work. 15 standards for creating a process. I don't think it's a standard for creating a process. 3-stage bootloaders, having separate bootloader for UEFI protocols. You are correct. We're gonna have a separate bootloader for UEFI, but I think what I'm gonna do there is simply compile it with a different configuration, remove some files, add some other files, so we're just gonna have stage 2 be completely different. And we're probably not gonna have stage 1 for the UEFI bootloader. I think creating a third stage is just too complex. It's just adding too much complexity to it. I don't want to add a third stage. Okay. So I hope this was clear. So to put it shortly, we're gonna relocate the stage 1 to a different address, and we're just gonna place it into config.inc. Then we're gonna reserve a sector somewhere on the disk. It doesn't matter, it's sector 1 or whatever. We're just gonna reserve one sector where we have this table, this data structure. And this table basically contains our entry point, and then it's gonna contain a list of what we want to load into memory. And this is very dumb. It's not gonna do any kind of relocation or I don't know, any kind of advanced stuff. It's really dumb. All it knows is I have to load this sector to this address. And in fact, no, not just this sector, but this number of sectors to this address. That's it. That's all it's gonna know. Okay. So let's get started. I'm gonna create this config.inc. And what I'm gonna place here, let's just add this include guard. And then let's just create stage 1 segment EQ, which is essentially like a define in assembly, in a NASM. And let's load it to address 700. I think there was something at 500 that... In fact, no. The reason why I went with address 700 is so that I can use this, the 200, which is more like, what, 1,000 bytes or something like that. So I can use that space for the stack itself, for the stack. Okay. I'm just gonna write a little comment here. Stage1 will relocate itself to this address. Make sure to leave room for the stack, which will grow downwards. Don't forget to update the offset in linker.ld as well. Since we have a linker LD, we're gonna have to update it here as well, and just change it to 700. And this comment is redundant. Okay, and now let's go to boot.asm, and I'm gonna delete this stuff here. And let's start from the beginning. So we want to include this config.inc file. So let's start with that. Okay. And now we have this jump, and this is where we write our code. All right. Now, something to keep in mind here. I am working in the C++ branch. The C++ conversion is not done. I'm seeing a question here. No, I'm not done with the C++ conversion. This is actually in the C++ branch that I'm working right now. The plan is to finish the conversion and also do all this stuff that I'm doing right now. All of it will be in here. Okay. So the MBR. Okay, now here's a little thing that I forgot to mention. There are two ways in which our bootloader can be loaded. If we are loaded from a floppy disk, which is not partitioned, then we don't have an MBR. So our code is the first that is executed by the BIOS. But if we are on a formatted disk that has partitions, then there's a little piece of code called the MBR, which lives in the first sector of the disk. And that little code, what it does, it looks for all the partitions. It searches for the primary partitions, basically, and tries to find the first one that has the boot flag set to 1 or whatever. And then it relocates itself and executes that boot sector as if it was loaded by the BIOS. So it's still at address 7C00, but yeah, it's done by the MBR. Now, when this happens, the MBR passes some information to us. So the MBR will pass us the following information. DL is the drive number. This also comes from the BIOS. The BIOS also does this as well. And then DSSI, partition table entry that we booted from. And this is why the first thing that I do here is to move the partition entry from the MBR to a different location. Okay. Okay, just looking at something. Okay, so let's see what we have here at the bottom. Instead of having this partition entry segment and offset, let's just reserve some space in BSS for that partition entry. And we know that how big it is. I think it was 32 bytes or something like that. Let's check. mbr dev. So basically the mbr just contains that code that I mentioned, and at the end of the boot sector, there's a little table that has 4 partition table entries, and each entry is 16 bytes, as can be seen here. Okay, and inside this address that I mentioned, the MBR will give us the address to which of these 4 entries it booted from. Okay, so partition entry, we're gonna reserve 16 bytes for the partition entry, and instead of this, which is no longer necessary. All right. Okay, so let's just simplify this. Copy partition entry to somewhere safe. Okay, and the segment, we're just going to use the stage 1 segment. And we're going to put it in ES. And then we're going to move the partition entry offset, which is now the partition entry variable, label, or whatever. The count is 16, and then we just call move sp, which is fine. Okay. And now we need to relocate ourselves. Okay, so how can we do this? It's actually pretty simple. All we have to do is just same as here, just use move sb. And we just need to set the registers to the SI and DI registers to the right values, and of course the segments as well. Okay. So first, let's set the data segment. This is the source, so our source is going to be 7C00. SI 7C00. DSSI is the source, which is 7C00. Our destination, we already set ES here. So let me just make this clear. So I'm just gonna leave these commented, but this is, I commented them because they're already done right here. And now we need to set the count, and the count is 512, and then rep move sp. So after this code gets executed, stage 1 will be copied to this stage 1 segment. I didn't set the stage 1 offset, so let's do that here. Move di stage 1 offset. All right. Yeah, that should be correct. Okay, so now we have a copy of stage 1 at this address that we set here. And all we need to do to basically start executing code from there is create a label and do a far jump. So jump to stage 1 segment and then relocate it. Var jump to relocated, cool. And now we are relocated. Now we are executing from this address that from 7C00. So the next step is to set up the data segments. DS and ES are already set. No, DS is not set. So we need to set DS to stage1 segment. ES is already set, so we don't need to do this. Okay, then we want to set up the stack. We're going to use the same segment, but we're going to set the offset to stage1 offset. Stack grows downwards from where we are loaded in memory. So basically, as I explained, this will be 700. From 700, 512 bytes will be the boot sector, and if we look before that 700 address, that's where we're gonna have the stack. All right. This is actually not necessary anymore. Read something from floppy disk. Okay, so in fact, what I do here, I don't read. Save drive number from DL, and I just set it to this EBR drive number, which is part of the header. That's fine. Okay, so I'm just gonna call this section initialization. I can't see the keyboard very well because of the microphone, so I make mistakes. That's okay. Okay, then we check that the extensions are present and all that. Okay. And that now we are after disk extensions check. Okay, so we've checked if the disk extensions are present, and based on that, we are going to call either the... Okay, this is fine. We're not gonna touch the code that reads from the disk. We're gonna change what we do here from this point on. Okay, let's go to the bottom of the file and let's change a few more things. Okay, let's have extensions. I can actually move this to BSS. BSS is basically uninitialized memory. So, okay, maybe it's... Yeah, maybe it's not such a good idea to move it, because we want this to be initialized to 0 or 1. But it's fine. It doesn't have to be initialized, because we move 1 or 0. We don't rely on whatever value it was previously. So that's it. One more byte saved. 1 byte here. Okay, let's see what else we have here. We have this buffer. The partition entry that I mentioned earlier. Okay, so now we need some piece of memory where to put that boot table that I was talking about. So let's just reserve another piece of memory here, boot table, and we're gonna reserve 512 bytes because it's gonna be 1 sector long. And then we also want to have the location for the entry point. After we parse it, we want to store it somewhere safe. Okay. So there we go. Then inside the data section here, we're gonna have boot. We're just gonna change, instead of stage2, let's just call this boot table LBA. And it doesn't need to be 30 bytes. It just needs to be, I think a double word is fine. Yeah, theoretically you can have 64-bit LBAs, but I'm not sure if the BIOS can even parse those. It might be able to. Okay, okay, fine. Let's just make it a quad. Okay, so this is gonna be an 8-byte value, which has this name, boot table LBA. And this is, if we're gonna put this boot table into sector 1, then this is gonna be set to 1. Otherwise, we're gonna set it to whatever sector we use to set that boot table. All right. What else do we need? Okay, let's create a structure. This is gonna be useful. This is how you create a structure, how you define a structure in NASM. It's just a NASM specific syntax. I'm gonna call it boot table entry. And we're gonna have a label for LBA. And same as here, let's just make it a quad this time. 1. Load offset, which is gonna be a word, so 2 bytes. The segment. And finally the count. And for the count, yeah, I'm using also 16, 2 bytes is fine. Okay, so since we're using this, I'm gonna update it here as well. So this is 8 bytes long. And this is gonna have 14 bytes and 14 bytes. Just to make this clear. And this offset is gonna be 20. Okay. Now, let's go back to this location after disk extensions check. Okay, and this is where we are supposed to load stage 2. So, what do we need to do here? We want to basically read this variable, which is going to be set by the this boot table LBA. This variable is going to be set by the stage 1 installer. It's just going to basically overwrite that particular field to whatever value we want to have. Okay, so we're gonna read this LBA from here, and then we want to read it from the disk. So let's go here. Okay, so in this next section, what we're gonna do is load boot table LBA, which contains the boot table. Okay, we want to store, we want to set this to boot table LBA. Yeah, even though it's a quad, we cannot really use it here because we do some calculations here. I'm not sure if we can even use the fact that it's 64-bit. Doesn't matter, whatever. So we're just gonna take the first 4 bytes. We're just gonna ignore the upper bytes. Yeah, maybe in the next time we do this, we might implement it properly. We cannot access RAX from 16-bit code. That's the problem, I think. So we would have to split it into 2 registers, which is getting a bit more complicated. I don't want to do that. Whatever. Let's just keep it to 4 bytes for now. I'm gonna change this back to 4 bytes. Just to make this easier to... Yeah, just keep it to 4 bytes for now. Okay. Okay, so EAX should contain the LB. Now, we're basically setting the parameters for that read function. That's what we're doing here. And this read has the following parameters. EAX contains the LB address, then CL should contain the number of sectors to read. DL should contain the drive number, and then this ESBX should contain the memory address where to store the data. I'm just gonna copy this so I have it next to where I'm using it. Okay, we've set EAX, so then we need to set CL to the number of sectors to read, so move CL1, just want 1 sector. Then the destination address is gonna be that buffer that I created. Okay, so move BX the address of boot table, and then let's do the read. The drive number is in DL. Let's check. Okay, it's still set from here, so we don't need to set it again. It should be already set. And call disk read. Okay. Parse boot table and load. Okay, let's put into SI the address of this boot table. First, let's parse the entry point. So the entry point, as I put into this readme, is basically the offset and then the segment. So it's just 2 fields, 16 bits each. Okay, so we are going to move to... Let's just move it to EAX, the contents of SI. So basically that first 4 bytes we're putting in EAX. And then we're gonna put it into the entry point thing that we did here. I'm just using a trick here to set both of these fields at the same time. Since we are using EAX, which is 4 bytes, we're just setting both of them at the same time. Okay, and then we need to increase SI by 4 bytes. Then we have this little table of boot table entries, and we need to parse each one individually. So we're gonna have a little loop. And let's have a convention. And I'm also gonna add this right here. Null table entry, and the null. Okay, and let's mention this here, contains all zeros. this is how we're gonna know that we've reached the last element inside this list, in this table or whatever. Yeah. Okay, so let's compare until LBA is 0. So compare the word SI. Okay, so the offset of that LBA is gonna be SI. And now we can use that structure that we defined. So boot table entry, this is the name of the structure, .lba. And NASM will be nice enough that it's gonna put that offset right here. In our case, this should be what? It should be 0 because it's the first field. Okay, and we're gonna compare this to 0, and if they are equal, we're gonna jump to end read loop. Okay, now we have to read. Okay, so we basically have to do the same thing that we did here. We have to set all these fields EAX to the LBA. So let's do that. Move the LBA, which is SI plus this ugly thing here. Then BX should contain the load segment. No, BX should contain the offset and ES the segment. So let's first set ES to, but we cannot modify ES directly, so we're gonna put it in BX first. Okay. And it's called load segment. And we're gonna put this into ES. Then we are going to set the load offset to BX, and finally the count into CL. So move CL SI plus count. Now this is gonna have a bit of a problem, and I think we should modify the read function to be able to handle this properly. But I'm gonna do that maybe later. Okay, and all we have to do here is call disk read. Yeah, so the problem here is that count is a 16-bit value, but we're putting it into an 8-bit value. So we're going to lose anything that's above 255. Now, what is 255? 255 multiplied by 512. That's about 130 kilobytes. So if we're gonna have more than 130 kilobytes for stage 2, then we might have a problem here. So I would want to modify this discrete function to work properly. What I was thinking... But yeah, I'm gonna do that later. I'm not gonna do that right now. Okay, so we're back here to read loop. Okay, so we've basically taken all the information from that boot table entry. We've called disk read, and now we should have that sector into memory, or that section into memory. Finally, we just have to increase SI by boot table entry underscore size. This is a really nice thing about NASM. When you create a structure, if you put the structure name underscore size, it's gonna give you the size of that structure, which is nice. Okay. So here we are reading, and then go to next entry, and then we're gonna jump to read loop. Okay, so we read all these entries from that table, and finally we want to jump to stage 2. And this is what's gonna happen here. We don't need this anymore, and we also don't need this loop anymore. So we should be here on the read finish. Jump to our kernel. Okay, so we are setting DL to the boot device. This is something standard we've done. Okay. Then we want to set DI to the partition. Okay, so we're gonna have instead of SIDI, I was thinking of just changing this so it's the same as whatever the... Oh, it's the same. Okay, DSSI. I think this is fine. Is there something I need from here? Okay, this is fine. So the partition, okay, the partition entry offset. Okay, so I remembered. The reason why I want to set this to DI instead of SI is so that it's nicely ESSI for ESDI for the location of the partition entry. It's just a little nicer because it's standard to use it. I don't think it matters that much anyway. Okay, so the partition entry offset. Okay. I'm just gonna set this to DI, and we're gonna use pass. Okay, I'm just gonna write it here. So ESDI point to the partition entry. Okay, next we need to set the registers to the right values. So ES we're not gonna change, we're gonna set DS to the segment from that boot and that entry point. Okay, so this will be entry point dot segment. Okay, so DS will be set to that the entry point segment. This is the segment that the stage 2 is gonna expect for the data segment. And then finally we do the far jump. So we cannot jump directly because they're not constants. We have them in memory. So what we have to do is push AX, then push. So we are pushing the segment first. Then we're gonna push the offset word entry point dot offset, and then retf. And this is essentially a far return. So what we're doing here, we're tricking the we're essentially tricking the processor into thinking that this is a return address. So we're just gonna push what the address we want to jump to, we're gonna push it to the stack, and then we're gonna do a far return. So this is exactly what we do here. Okay. And at this point, we should not be in this stage 1 anymore. Let's just say never, because this should never happen. If this happens, then we're in trouble. Something has gone terribly wrong. Okay, And I think I am done with stage 1. Yeah, let's do that thing that I said in the discrete method. So if we have extensions, let's see what this count is. Okay, so if we have extensions, then we can use... no, it's not that one. It's this one. If we have extensions, if we have boot extensions enabled, then we can use a word for count. So this should be fine. Okay, so discrete, where was it? With extensions, and instead of just pushing CL, we're gonna put CX in there because this is a word, so it should fit properly. But if we don't have disk extensions, then we should probably do the read in a loop, which is a bit annoying to implement here. So okay, if we are using the interrupt, the int13h interrupt without the disk extensions, then it's expecting the number of sectors to read in CL. But we might have more than whatever number is in CL here. So we should probably change this a bit. Do we need to CX for anything? No, we don't. LB to L. Ah, damn it. Okay, so we are using CX to store the sector number of the cylinder, which is a bit annoying. Okay, so what registers are we not using? I think SI and DI are not being used here. And we can actually use those. I don't see them being any parameters here. So what we're gonna do is, if we don't have any disk extensions, we're gonna put the count to DI or SI or something like that. Okay, but we also have something else that we need, which is the LBA address in EAX. So let's save both of them. Move ESI, EAX. So save LBA to ESI, and then move and then save number of sectors to DI. Okay, and then we're gonna have the outer loop. And inside this outer loop, we're basically going to copy the LBA from ESI. Okay, so we're gonna copy it into EAX. Then we are going to call LBA to CHS, which is gonna convert it from LBA to the cylinder head, whatever sector. And then we need to set the count, and I'm just gonna set the count to 1 instead. And we're gonna read sector by sector, because this doesn't work very well otherwise. Okay, so AL is the number of sectors to read. We can just set AL directly to 1, and then AA. And then we have AH, which is the function number, and DI. Okay, so we stored the retry count in DI. Okay. We need one more register here. What else is not being used? I think BX might not be used. I'm not really sure. No, it is used. So AX, BX, CX, and DX are all used. DH is not used, but I think... it's not gonna work. Okay, that's annoying. What I think we'll have to do is just use the stack and push something to the stack and then pop it Okay, I'm just gonna push this number of sectors to the stack. Okay, we're gonna push di to the stack, and then we're gonna set the retry count, and we're gonna set all the other stuff, and then we're gonna retry. All right. Okay, and now we try to read up to 3 times. And if this fails, then we're just gonna call disk reset. And then we're gonna try again. All right. And this looks fine, but if we fail the 3rd time, all attempts are exhausted, then we're gonna jump to floppy error, and that is also fine. Okay, and when we are done from this inner loop, we have to undo what we did here. So we have to pop di. Okay, so now we are in this outer loop. I'm just gonna do a tab here to make it more clear that we are inside this loop. Okay. Okay, so what we have to do here next, we've restored di. So now EAX has the LBA and di has the number of sectors to read. So we need to decrement these two. We need to decrement the number of sectors from di. In fact, let's put the exit condition here. So if di is 0, then we're gonna jump. If equal, we're gonna jump to third loop end. Okay, so basically what we're doing here is we are reading one by one each sector, and then after all this loop, we are checking if we have reached the last element. If we haven't reached the last element, then we're gonna decrement di and increment ESI, which is the LBA we want to read. And then here, decrement number of sectors. And jump to outer loop. Okay, I think we are good here. I'm gonna check one more time. So, if we have no disk extensions, we are saving the LBA to ESI and then the number of sectors to the DI register. Okay, and then we reach this outer loop. Here we are doing this conversion from LBA to cylinder head sector, which is what that read function expects. The number of read one sector Okay, so we read sector by sector, then we save whatever value we had in DI, which is the total count, and we put there the number of retries, and then we set the function. We do this loop here, which tries a couple of times, and when it is done, we're gonna pop everything that we pushed here inside the loop. And then we're gonna restore DI to its previous value that we pushed here. And then check exit condition. Okay, if we have read all the sectors, then we're gonna exit. And here we're just doing whatever we did here, but in reverse. So pop di, si, and so on. So this is looking good. And then we return. Okay, this is looking good. I am hoping that this is gonna work. Okay, now let's take care of the next thing on our list, which is the linker script. There's something I missed here. Okay, so I have this BIOS footer, which contains the AA55, the signature required by the BIOS to boot our image. And here, instead of using this absolute address, we should do a calculation. So it should be fis plus 1FE. And this looks good. Okay, let me check if I didn't miss anything else. Okay, now let's go into this build. Something I don't have here is I'm not depending on the header. So even if I change this, it's not gonna rebuild. So I want to fix that. Headers equals globe recursive, anything that ends in .inc, and we're gonna add a statement here at the end, env.depends, and we're gonna say that stage 1 depends on the headers. Okay, another thing here is we need to tell NASM that this should be our include directory. So -i, and then env dot the current directory from this target environment dot crc node, source node. And what this does, it's a SCORN specific thing. This is going to give us this stage 1 directory. And if we don't put source node, it's going to give us the destination node. And the destination node is essentially where it builds everything. And we don't want that. We want the source node, which is where the source code is located. And this is why we use source node here. Okay, I think we are done with stage 1. Yes, we are done with stage 1. Now let's go to stage 2. Yeah, I'm gonna do the same that I did. Headers, anything.h or hpp or inc. Because I didn't handle this properly. Okay, now in stage 2, we're gonna have a small difference here. Instead of si and di, I have the offset in di and the segment in es. So this is what I'm changing here. And that's basically it. Okay, next thing we want to change in the stage 2 is this linker script. And let's do this. Let's change it from binary to ELF. So ELF 32-i386. And we're also going to change the address at which we load stage 2, because right now at address 700 is stage 1 and we want stage 2 to be after stage 1. And I think a safe address would be 1000. This should probably be fine. Okay, Now let's go to the build process and let's implement our magic thing in the build process. Now, from now on, stage 2 will not be a normal, it won't be a flat binary anymore, it will be an ELF file, and we need to parse it. So how can we parse this file in this scon script? How can we parse an ELF file from Python? Guess what? We import a library, because that's how we do things in Python. So let's go ahead and import this ELF. The library I'm going to use is called ELF tools. I think I already have this installed. Let's check it out. PyElf tools. Okay, so this is what the library is called. You just install it using pip install PyElf tools. And in fact, let's add this to our README here. So in addition to this, we also need PyElf tools. Also on Fedora, also on Arch, and so on. I already have this installed. Now let's go here to the image, scon script, and we're gonna modify this file. Okay, we don't use this, we don't use this, we don't use this, we don't use this. Just a little cleanup here. All right. And now we are going to also need from elf tools.elf.elf file, import elf file, and there's another one that we also need, which is elf.descriptions describe ptype. Okay. Now let's go to install stage 1, and I'm gonna write a little documentation here as well. To the given disk partition. Okay, and let's also add some additional information here. So stage1.bin is expected to have a stage1.map file accompanying it. Okay, so this is what the install process looks like. First, the fis, which is the physical address, and entry start symbols are read from the map file. And this is what we do here. We read entry start, and we are also going to read that physical address by subtracting this. We can obtain the offset of the entry start symbol in the bin file. Write the first 3 bytes. In fact, I'm just gonna copy this from the... What's the point of writing this by hand? Okay, so the basic idea here, the way stage 1 currently is being installed, we are basically reading that map file, which is generated by the linker. So let me open it and show you what it contains. Stage1.map. And here we can see all the symbols that we care about. We care about, for example, the entry start symbol. which is gonna be where we need to... Okay, so it's gonna start with this. Okay, it's called entry. Entry start. Do I see entry start here? I don't. Okay, there it is. So the idea here is we have this big header at the beginning of stage 1. So the first 3 bytes are this short jump, which are gonna jump to this symbol right here. Now, what we want to do here is we don't want to use these values that we set here. We want to use whatever the formatting utility used. So what I'm doing here is I'm basically skipping over this entire region. And to determine where the code begins, I need to find that symbol inside the map file. And this is exactly what's happening in this scan script file. This is exactly what I do here. I look for the entry start symbol, which is where the code basically begins. And I also had this stage2 start. So previously, if you remember from an older live stream, the way I implemented this was I had a few bytes reserved inside this stage 1 file where I could put the LBA where the stage 2 starts, where it begins, and then I would load from the disk from there. But now I'm not using this approach anymore. I am going to modify this. Because now we have a different variable, which is the boot data LBA. So instead of stage 2 start, we're simply looking for boot data LBA. Okay, now instead of subtracting 7C00, which is not correct, because now we have relocated to a different location, we also need to find the FIS symbol. So we're just gonna search for FIS as well. Okay, and now we have the physical address where that stuff begins. Okay, so now instead of subtracting 7C00, we're just gonna subtract FIS. Okay. Then we have this code here, which essentially goes to the beginning of... Okay, let me see. Let me try to understand. Okay, so when we install stage 1, we have this offset here, which tells us where we want to place stage 1 in the image file, where the partition begins, essentially. So we seek to where the partition begins. We write the first 3 bytes. Then we skip over the next couple of bytes which contain the header of the file system. This is what we do here. This is why we do these 2 seeks. And then we continue writing the rest of stage 1. Now, here we are going back a little bit. So we are seeking relative to the beginning of the file. We're gonna seek back to where that location is. And instead of stage 2 start, this is gonna be boot data LBA. And now we want to write here that boot data LBA. And previously this was given as a parameter here, but we're gonna change that to boot data LBA. And we only have 4 bytes to write. So 2 bytes, 4 bytes, and the byte order a little Indian. All right. And now we have stage 1 installed. Now let's see what we need to do for stage 2. This is where things get a little bit more complicated. Okay. Okay, so stage 2 is where things get a little bit more complicated, because now it's not a simple binary image that we just write to this offset, to the disk. Now, stage 2 is an ELF file, so we need to parse it as an ELF file. Okay, I'm gonna copy this little comment that I wrote here as well. Okay. And in addition to this, I will also need boot data lba. Okay, so the basic steps are outlined here. First, we need to read the ELF file. We need to basically extract that program. I don't know what I did here, because this doesn't make sense. Okay, so the ELF file is parsed. This is the first step. Then we save the entry point to the boot table, and then write the program file to disk, the program to disk, okay, and then save the entry to the boot table. Put the details on how to read the program to the boot table. All right, so that's basically what our process is. Okay. Now let's see. So instead of this, we need to modify. So we have opened we have opened both stage 2 and we have also opened the output, which is this f target. Okay. First, let's parse this stage 2 as an ELF file, and we're gonna use this ELF file class, which is coming from that Python library that I mentioned earlier of stage 2. And now we need to parse the entry point. And here we will also need another function, address to segment offset of stage 2 ELF. And the way we access the fields from this ELF file is simply used as a map. So e_entry will give us the entry point. Okay, now we need to implement this address to segment offset function. So let's do that here. And the way we can do this, there are multiple ways in which we can do this conversion. The way I chose to do it for this is to essentially okay, so let me just explain this a little bit. I'm gonna close all the other files. Okay, so if we do the formula for the segment and offset, it goes basically like this. So when the real address, so linear address, is equal to segment multiplied by 16 plus offset. And we need to do the opposite. So we need to convert from a linear address to a segment and offset pair. And we can approach this however we want. We can, for example, take, so let's say that the linear address is like this. 1, 2, 3, 4, 5, 6, 7, 8. Let's say that, in fact, this is a little too big for address. Let's just use 1, 2, 3, 4, 5. Let's say that this is our linear address, and we're gonna split it into 0, 0, 0, 1, which is the first half, you know, the upper half, and then the lower half, 2, 3, 4, 5. And all we have to do here is simply take one of, for example, we can take this and multiply it by 16. And use this as the offset, or we can do okay, so we can basically take this as the offset and then have this be the segment. And the segment in this case will be this big number divided by 10. So it would be like this. $1,000 and then 2, 3. This would be the segment, and the offset would be 2, 3, 4, 5. This is one way to do it, but we could also split it somewhere else. Another way I did could be to have the segment be these four, so 1, 2, 3, 4, and then have the offset be just 5. So there's a lot of ways in which we can do this. Yeah, so the way I choose to do it is to just use this as the offset, and then divide this big number by 10 and have that as the segment. So that's what I'm going to do here. FFFF 0, 0, 0, 0. So we're basically just masking everything except for these. Yeah, we just want to take these 4 bits, 4 digits here. It's 2 bytes. These 2 bytes here. Okay, and then we want to divide this, shift it to the right by 4 positions, but yeah, okay, so we want to divide this by 16, which is the same as shifting it to the right by 4 bits. And the offset is gonna be address and 0x 0000 FFFF. So just the lower 2 bytes or 16 bits. Okay, does this make sense? I'm kind of I've been streaming for a while, 2 hours. Oh my god. And I'm already kind of stressed and nervous, and I'm starting to make less sense. I'm getting a bit tired. I'm sorry. I'm doing my best here. And let's return. And what will we return here? We could return the pair of 2 numbers, segment and offset, but let's just make things simpler and encode this into whatever we expect when we parse it here in stage 1. So in stage 1, what we have is, let's check first and then we will do it. First we have the offset and then we have the segment. So the segment would be in the, since this is little endian, the offset will be in the lower part and the segment will be in the higher part of this 32-bit number. So we shift the segment by 16 and then add the offset like this. And that's basically it. Okay. So now we have the entry point and we're going to store it into the table. Actually, let's do this at the end. Let's create the boot table now. And we're going to create a simple list and we're going to iterate over all the basically all the program sections from this elf file. Okay, so for segment in stage2 elf dot iterate segments, this is how we iterate over the program segments inside this with this library. If describe p type, this function will basically give us let me show you. The p type is basically this. We're just looking for the program headers that have the type load. So the if describe p type of segment of p underscore type, because by default this is just gonna give us a number, and describe p type is gonna convert that to a string. Okay, so if the segment type is load, then we want to extract the data. And then we want to count how many sectors this data has. Let's import math for that. And this will be the ceiling of the length of this data divided by sector size. Okay, now let's append an element to this boot table, and then we will write it at the end. So let's see. Okay, LBA is going to be the current LBA, which we don't have yet. We need to create it. Okay, so initially this current LBA will be the offset. Basically, if we have multiple program sections in this elf file, each one of them will be put consecutively. And offset, this is the location where we want to store stage2. This is actually not correct. It's not the offset where partition begins, but offset where to store stage2. Okay. Then the load address is going to be address to segment offset of segment of pvaddr. So this is gonna be this virtual address over here. All right, and count is going to be len underscore sectors. Next, we want to write the data. So we are going to seek to current LBA multiplied by sector size. And we want to seek from the beginning of the file. Then we are going to write data, and yeah, that's it. And then we are going to increment the current LBA by the length in sectors. Okay, let's not forget to add this null table entry. So this is what I'm doing here. Boot table dot append And yeah, let's just set everything to 0. So LB 0, load address 0, count 0. Okay. And finally, we are going to write this boot data. The question is, where do we write this data? And that's what we have the boot data LBA for. All right, so we are going to seek to boot data LBA multiplied by sector size from the beginning of the file. And then let's, we're gonna write entry point 2 bytes. Okay, and then we're gonna write all the entries in this boot table. And we have 3 fields. First, we have the LBA. Then we have the load address, which is also 4 bytes. And then we have the count, which is 2 bytes. Okay, and I think this is looking good. Okay, one last check to make sure that this is correct. Okay, so we are opening the stage2 elf file. We are basically taking the entry point and saving it as a real address with segment and offset here. Then we are building this boot table with all the entries from this program thingy. Okay, from the program segments. Okay, then we iterate over the program segments that have the type load, which are the ones that we want to store. We're taking the data, we're calculating the number of sectors, and then we are writing it to the disk. And then finally we write this boot data structure. Okay, this is looking great. Let's go to okay, now let's try to think how to, let's see how we need to change when we build the image. Okay, so inside build floppy, here what we are doing is we are creating a file system. And we need to have a few reserved sectors. This is basically we're creating a file system that inside this image file of the type fat12, having this number of reserved sectors. And previously this was the number of sectors required for storing stage 2. But this time we will need a little bit more than that, because we need stage 2 sectors plus 1. Now something that is not correct here is that we haven't actually parsed the elf file and we don't really know exactly what the length is. But it's fine. It's okay. We're just gonna leave it like this. Even though we reserve more than we need, this should be fine. It shouldn't be a problem. Okay, then we install stage 1. And here we're gonna use the boot data LBA. It's gonna be 1. So instead of having, let me just make a very quick schema here. So previously what we had was basically this stage 1. So this is boot sector. And then we had stage 2 inside. This is the basically reserved sectors, and here we had stage2, and then we had the file allocation table and the rest of the stuff. And then the root directory, and finally the data. This is basically what the fat file system looks like. Now, what we've done here is we've taken one of these reserved sectors, being the first one, and here we put this boot table, and then we have stage2. So everything basically shifts. All right. So let's make the changes we need to achieve this. Install stage1. This has target image. Stage1 is this file, and then the boot data LBA is going to be 1. Then we are going to install stage2, but this time we need to install it to offset 2 because the first sector 1 is reserved for this boot data structure. Okay, and here we also have this boot data LBA that we need to pass, so let's do that. Okay. All right, this looks good. Now let's see the other build function, which build disk. And we also need to update. This. Okay, so when we have multiple partitions, the way this looks is a bit different. I'm gonna need Excel for this because it's more complicated. And I'm gonna make a little drawing so you can understand it better. Okay, so let's say that this is partitioned disk. Okay, so we have the boot sector, which contains the MBR. Okay. And as I mentioned before, this MBR basically contains a little piece of code which is going to search for the active partition. And then it's gonna boot from the first active partition that it sees. Okay, then here we have some padding space. This space right here is essentially not used for anything, but we do use it to store stage2. Then we have partition 1. Okay. We have partition 1, and let's I'm gonna use let's merge these cells to make it more clear which one. All right. Okay, and inside this partition 1 we have stage1 as the boot sector. So this is essentially the boot sector of partition 1, which has our stage1. And then we have rest of file system. This doesn't matter anymore. So this is basically the rest of the file system, the file allocation table and everything else. Okay, so the way this worked. Okay, so when we have this partitioned disk, we want to install our boot sector inside partition 1, and we want to install stage2 inside this padding space in between the boot sector and partition 1. As you can see here, after creating the partition table, I create the file system. And as the offset, I have this partition offset, which is set to 2048. So this will be essentially sector 0. This will be sector 1. And so on. So this is 1 to 2047. And this is 2048, basically. So we have basically 2048 2040, what? 2046 sectors of space that we can use to store stage 2 here. And even if that's not if our stage 2 grows beyond that, we can basically just move this further away. Okay, is this clear for everyone? I hope this is clear, okay? So what we're doing now, we're basically splitting this stage 1, this stage 2 space, and it's still this padding space, so it's still that padding space, but we're just gonna take the first sector and we're gonna put this boot table here, and then stage 2 will begin from LBA number 2. So this is the new layout of the disk, basically. All right. So install stage 1. The offset is gonna be the same, partition offset. This is correct, but instead of having stage 2 offset, we're gonna use boot data LBA is gonna be 1. So we're telling it that this is at LBA 1 is where it can find this boot table. Okay, and then we install stage 2. This time we have to install it at offset 2, and we also need to tell it boot data LBA equals 1. Okay. It also has this limit that I don't think we are checking. The idea here is to give us an error if if this stage 2 grows larger than that partition offset, but I haven't done that. I think we can actually do that. Okay, we can basically do it here. So if the current LBA is greater or equal to the limit, then we can raise an exception. The stage 2 is too big. It is overwriting partition 1. Okay, I think this looks good. We don't need this calculation anymore, so I can delete it. And let me see what else I need to change. Yeah, basically that's it. So now it should work properly. Okay, these are not needed either. Now, for the moment of truth, does this work or does it not work? Let's see. And it doesn't work. Okay, so we have a little error at line 146 in stage 1. So the problem 146, the problem is this. Oh, okay, it should be add si4, not inc. Okay, and then we have another error at line 168. Partition entry segment. Oh, okay, this is not correct. Wait, why is this still here? Okay, so in DI, I wanted to set the partition entry like this. Okay, now this should be correct. The drive number in DL, ES is already set, and DI should be set to the location of that partition entry. Okay, this is looking good. Let's try again. Okay, so we have an error. BIOS footer overlap section RO data. Why could that be? Let me check. Okay, so maybe this section is too big, or some other section is too big. Let's see. I think we might have too much code. That's simply the problem here. We have too much code. Do we use this variable? Kernel not found error. What? I don't use this. Okay, we found something to delete. So I don't use this message anymore. So I don't have message stage2 not found. And I don't use this one either. Oh, look at how much space we can save. Okay, let's see. Okay. Cannot find boot data LBA symbol in map file. I wonder why that is. Because I called it boot table LBA, not boot data LBA. That's the problem. So let's just rename it to boot table LBA inside here. Stage 1, boot table LBA, and that should be fine. Okay, one more error. String object has now attribute seek. What? What did I do here? Okay, I know what is wrong. So inside here, I'm not using the file, I'm using the string which contains the file name. That was the problem. Okay. I'm still getting that device or resource busy. That's annoying. Okay, I'm just gonna switch to guestfs. That should work fine for me. And now I have to unmount all these. Oh my god, what's going on here? Okay, now this looks clean. And now let's get rid of all those loop devices. So hello setup -t dev loop. Let's see if it can do. Fail to use device, no such. Okay, I think it worked. Did it work? It was -d, right? So okay, so it has detach all. Okay, nice. We can use that. If you're on Ubuntu, don't use detach all. Okay. I'm not sure why I'm having that problem. It's a strange issue in Python. I don't know, maybe I need to update it or something. I have no idea. But I tried it and it worked fine on Windows subsystem for Linux. Okay, so I'm just gonna set it back to guestfs. And here it's working. The delay is working. Oh, okay, so we're still getting the device to resource busy. I don't know. I honestly don't know what the problem is. It's a very strange error. Am I doing something wrong? So I'm just calling unmount.fs on that directory. Yeah, this should work. I don't see any reason why it shouldn't work. It doesn't work. Strange. I don't know. Having some strange problems here. Okay, so that temp file is still there, so it maybe didn't unmount it. It worked. Device for resource busy. I don't get it. Seriously, I don't get what the problem is. I'm having a strange problem here. Oh, I know what's wrong. I figured it out. I forgot to add the mount method here. And then mount token. Oh my god, that was the problem. Alright, that's why nothing was working. Okay, so I have okay, and this one is still mounted, so we need to unmount it. Mount -u. Okay, now it should work. We can actually try it with mount to see that it works. I found the problem. So if I set the mount method to mount, this should work. Okay. And it's actually sleeping, which is great. Yeah, we can actually reduce that sleep. It's where is it? Where is it? Where is it? Okay, let's just sleep for 2 seconds. It's gonna be fine. We don't need to sleep too much. Yes, it worked perfectly. Yay! I fixed this problem as well. Okay, now let's see if it actually comes run. Okay, we're getting read failed. That's fun. Debugging is fun. All right, let's debug. Okay, and since we're getting a read failed error, let's go ahead and first, I want to check the image file that it was generated properly, that I didn't make any mistake there. Let's open up a hex editor, and I'm going to get the image file in here. Oh, my eyes, what is happening here? Hex colors, foreground, background. Zebra color should be black. Oh yeah, that's better. Doesn't look right because it's purple, but I'm gonna make it not purple. Okay. Yay. Okay, so what we expect is first let's go to okay. Can we make this larger? Yes, we can. Okay. And let's make it so that only... Okay, like this. Okay, so first, we are expecting... Okay, this is gonna be the MBR, which is gonna end here. This is the MBR, and then we have this table that we have created. And if we look here, the entry point is sector 0 address 1000, which is correct. And then we have that structure that tells us first we have the LBA, which is 00000002, so it's 2. Then we have the address at which we want to load this data, which is 0000 and 10000. So it's 1000. Can we make it so this is in hex? Hex. Where is hex? It doesn't matter. Anyway. So this is correct. The segment is also 0, which is correct. Okay, so LBA, segment and offset, and then this should be the size. So the size is 27 sectors. The next 27 sectors we expect starting from 400. Okay, so we have data here, which looks good to me. I remembered something. In stage 1, I did a mistake here. I forgot something. And I'm gonna fix that before moving on. Here I made a little mistake. Inside this disk read function, we have incremented. So we are reading in a loop. We are reading sector by sector in a loop. But what I forgot to change here is to increase this address where we store the read data. Oops. So we need to fix that. Okay. I think BX is yeah, okay. So it here in the outer loop, when we increment the sector, we decrement the number of sector, and then we want to add to this address that we have here in ESBX, we want to add 512, but we're not going to add it to BX, we're going to add it to ES. So this way, if we have to read like multiple sectors that cross that boundary between sections, between segments, if we have to cross that boundary, we won't get into trouble. So we're going to add 512 divided by 16. Increment destination address. Use segment to avoid segment boundary trouble. So that should fix the problem. Let's see if the assembler is happy with this instruction, or if I should do this with an intermediary register. We're gonna see. Okay, come on. Nah, sconce. Invalid combination of opcode and operands. Oh no. 345 here. What can we do here? We can use AX because we don't need what's in there. Okay, so first we're gonna move the contents of ES to AX. We're gonna add AX this, and then we move it back because the assembler is not happy with what we did here before. Yay, okay, that is working. Okay, the recording of this live stream, the recording of all the live streams that I do are available on my channel. You can find them there. And I'm also adding them to the playlist, yes. Why do I have Python? The build system is sconce, which uses Python. Can you shortly explain how to run after cloning the repo? Don't get sconce to work, thanks. I'll do that later. I will remember to do that later. Thanks. Makefile doesn't work in part 1. Okay, if your makefile doesn't work, please come to our Discord. That's the best place to get help. Or you can leave a comment with the error you are having, and we can try debugging that way. Hello, hello, hello. Yes, you're welcome. What is going on here? Yes, what is going on is we're making some improvements to the bootloader. And we are trying to make stage2 be an ELF file so that we can debug. Okay, sconce run. Boot failed, read failed. All right, so we're still having some issues here. Let's try to debug. Sconce debug. And now we have this beautiful camo. Okay, let's first put a breakpoint at 7C00. That will be where our stage 1 is located, and then layout ASM so we can see the assembly code, and layout regs so we can see the registers, and continue. Okay, we are now at 7C00, but this time it's not gonna be, we're not gonna break in our own code. Now we are in the MBR code. So we need to continue one more time. And now we are in our own code. Okay, and let's step instruction by instruction. Now, I'm noticing a problem that I've had before, and I have a fix for it, but it's not very pleasant. Apparently there's been some change in GDB that it cannot display the real mode variables anymore, registers correctly anymore. As you can see, it's just having layout ASM. As you can see, it has AAX and EASP, and it has like 32-bit versions of everything, and it looks all messy, and something's not right here. And I've had this problem before, and I will attempt to fix it. Okay. The way I fixed this problem before was to download a specific file Let me find it first. I cannot find it. Oh yeah, I think... Just a second, let me find that file. I cannot find it at the moment. Okay, so the basic problem is something has changed in GDB. And what I can do to fix that is by placing this target file in somewhere around here. I'm gonna put it in scripts. Why is base not working? Come on. Okay. This is a simple file that basically contains a reference to the architecture, and it's got this i386 32-bit XML, which I'm also gonna copy. I think this file was taken from the source repository. If I remember correctly, I've seen this issue on Stack Overflow. So GDB 16-bit code not working or something like that. And someone posted this problem before. Yeah, so for example, they set the architecture manually. I tried this and it did not work. The only thing that worked was to basically add this file manually, but I don't remember how I got to it. I found it on Stack Overflow, definitely. Yeah, here. And this is the problem. There's some misbehavior in recent versions of GDB and Chemo. It's an open issue on Sourceware, and the way you can work around it is by downloading this target XML file, which looks like this. I think this is exactly this i386 file, yeah, that I added manually. Where did I lost the answer? I had it for a second. Which one was it? Okay, this one. I think. I don't remember. Anyway. Okay, this is the one. And then you use this set tdesk file name, and then you give a path to that target XML file. I'm gonna commit these files both to Git in case you have this issue. So now let's go to debug.sh. This is where I have my instructions on for the debugger. And okay, so what I need to add is basically this line. After setting the target, set tdesk file name, and then pwd, this is the current directory, scripts, target.xml. All right. Let me do a few more things here. I'm also gonna set the layout because we tend to use this a lot. And let's also put a breakpoint here. And then continue. So now when we type in GDB debug, And let's do 2 continues. Actually, no, just 1. That's okay. Hold on. So the first continue is gonna continue until it reaches 700. Yeah, that was correct. So 2 continue so that it reaches our boot sector. And now when we call debug, yeah, it works now. Okay. Yeah, so let's put GDB here to the side, and let's also put our code here to the right. And let's see what's going on here and why it's not working. I definitely messed something up. I don't know what. Okay, so the first instruction is this jump to start. So let's step over that. And now we reach this section here. We are setting stage 1 segment, which should be 1, 0, that is correct. Then the partition entry is at B01. Remember that this is in the BSS section. We are theoretically loaded at address 700. So 700 plus another 200 is 900, and then that's where our BSS section begins. 901 is gonna be this, and this is gonna be 900 plus another 200 basically in hex. So 9AB, B01. And yes, we are at B01. That is correct. All right, let's move on. We are setting CX to 16 because we are copying 16 bytes, and then we have this copy instruction. Okay, is it gonna make me step through every... Yeah, all right. And then we are going to relocate ourselves. All right, let's just assume that works and put a breakpoint at 700. No, star 700. That's how you put the breakpoints. And then continue. Ah, damn it. I forgot. Because we're not jumping to address 700. We're jumping to 700 plus whatever this is. Okay, I'm gonna have to restart this. Okay, it's always fun. Okay, so let's just step quickly over this. Okay, so we are jumping to 77C. In fact, let me just place that in debug directly so that we don't have 77C. Okay. And we are gonna remove one of the continues. Okay, so this way, the next time we are doing this, we will have the breakpoint already set to this location, and we don't have to go through this code again. Okay, and let's do the same here. Break at 77C and continue. Okay, and now we are at 77C. Okay, so first we are setting up the data segments, which is 0 as we expect. We set the stack pointer to 700, which is correct. We save this DL to some memory somewhere, which is okay. And then we check if the extensions are present. Okay, let's jump over this. I don't want to see this. This should probably work. So 7, the address is 792. And continue. Okay, and we got our response. Let's see if it's gonna jump or not. If it jumps, then it means that we don't have disk extensions. Okay, step instruction to jump if below. That's what JB means. And did it jump? I cannot tell. No, it did not jump, because now we are at this instruction. Compare BX to AA55 and what? And if they are not equal, we are going to jump to no disk extensions. And we haven't jumped, so we do have disk extensions. Great. Okay, and now we are here. Okay. So the next thing we are doing is we are setting EAX to the boot table LBA, which is not correct. Why is this not correct? It should not be 1cc. That's not correct. So I think something went wrong here. Boot table LBA. Why is it? Okay. Let's see what went wrong. First, I'm going to verify that 8cc is the correct address for boot table LBA. Let's check. Let's just be sure. Build stage1 .map, and if we search for boot table LBA, it is 8cc, so that is correct. Now, let's see if we have an error in our install code. Okay, so we are trying to find this symbol. And then we are seeking to the location of this boot data LBA, and then we are storing it. Let's print some stuff here. And to make sure that everything is working correctly. So, hold on a second. Hold on, because I think we have a little issue here. We have a conflict of variables. So we have this boot data LBA, which is the value that we want to write. And then we have this, which is overwriting it in the file. Okay. Let's give it the correct name then. Boot table LBA. And then we want to seek to the boot table LBA. And we want to store the boot data LBA. So that was the problem. That was the bug. Okay, I don't think it actually did anything. So let's... yeah, unfortunately, with sconce, it's not going to rebuild if you modify a source file, a sconce file, basically. So, just gonna run it again. Password, okay. And now let's see if it runs. Okay, we're still getting a read failed. But let's go back to the debugger. Okay, and now we are at address 77C. So we are back to right after this relocation. We are right here. Okay, I want to move on a little bit faster here. So let's jump to 792. 792, continue. Then let's, okay, we can step by step here. We know what's gonna happen. Okay, and now we have put, okay, so it's LBA1. This is correct. Now it's correct. Okay, we want to read one sector, so we are, okay, I found one more error, and we have to fix this one as well. So remember that in the discrete function, we changed it from storing the number of bytes to read, the number of sectors to read in CL to CX. So here we need to use CX instead of CL. That's the problem. Okay, so when here, instead of putting it in CL, we're going to put it in CX. And hopefully that fixes the problem. We will see. Read failed. Okay, putting a breakpoint at 792. Continue, step. Okay, so we are reading one sector. We are placing it at address B11. Is that correct? B11. Yeah, I think it is. Yeah, because it's the this is basically like 10 in hexadecimal, so yeah, it is correct. And then we are calling this function at 846. So let's step in and see what happens. Okay, we are checking here. So let's go to disk_read. All right, we've pushed all these things to the stack, and now we are checking if we have extensions. Okay, and if we don't have extensions, we're gonna jump. Okay, we do have extensions, so now we are here. Okay, so we are setting the LBA into this variable here. Let's see if this is correct. Okay, so this is a D word, so it should be 4 bytes long. And we are putting from EAX, which is LBA1. That's what we want to read. Then we want the ES segment, which should be set to 0, probably. Info regs. Info reg. ES. ES is 0. Okay, so ES is 0. Okay, let's see what's going on here. Okay, this looks correct. Then we're putting the address at which we want to write, which is B11. And then from CX, we're copying into this count. Let me make sure this count is okay. It's a double word, so it's a word. So this should be correct. And then we are setting up all the arguments. Okay. Let me go back. Okay. Oh, okay. So this is the problem. I figured it out. So before I was basically sharing this retry between both methods. And the only difference being what value I set here. And it would retry 3 times. But this is not gonna work. So let's fix this. Unfortunately, I just have to copy this code here. Okay. So theoretically, what else was I doing here? Okay, let me check the history. So I don't make a mistake. Inside disk read, I was jumping to retry. Okay, so I set the variables here and then I jump to retry. And then there's the stuff that happens when there are no disk extensions, and then there's the retry block. All right. Okay, so what we have to do now is basically whatever we did inside this retry block. I'm gonna rename this to function end, so it's more clear what it does. Okay, so if we are done, I'm gonna jump to function end. This is a mess. Okay, and then we're gonna jump to retry. Okay, that's okay. And we have fail. Okay, this is fine. And we don't no longer need this. Done. Okay, and if we don't have any disk extensions, then what we do is this code here. And let's just, to avoid any kind of problems, I'm going to rename it to inner retry. I think it should be fine, but I'm not certain. Okay, I still need that done here because there was something. I need to pop all the registers that I'm pushing here. And then I'm gonna jump to function end. Okay, I'm gonna call this inner, done, to avoid any flag issues. Okay, and I think this should be okay. So, what is happening is this, we have this code here that's setting up all the variables for this retry, and then we are going to retry this 3 times. When it's done, it's going to jump to this label here, which is going to undo this pop A. Hold on. Yeah, it's going to undo this push A. And if it fails, it's just going to go to floppy error. Okay, and in the no disk extensions case, we have this outer loop, and then we have this inner retry, where things are a bit different. And finally, we go to function end, which is just cleaning everything up and returning. So I think this looks good. Hopefully this works. This grid will fail inconsistently defined. I think I have two fails, yes. I'm just gonna call this inner fail. Inner retry not defined. Why is it not defined? Oh, I forgot the little dot. Okay. And let's see. Okay, now we're talking. Now we are in stage 2. Yay, it works. Whew. Yeah, I'm going to commit these changes. And I'm going to end this live stream right now because it's been quite a long one. I've done quite a lot of progress, and I'm happy with that. Let's do one more thing. Let's test that we can debug with symbols. Let's go to debug. I'm going to delete this stuff. This is just for my own debugging, basically. And let's also add one more symbol file. Stage2, stage2.elf. Okay, and now let's try to debug. Where's my terminal? I cannot find my terminal. Did I close the terminal? Yes, I did. All right, and let's try to debug. And error. Oh, stage2.elf is missing. Oh, I think I forgot something. In stage 2, here, we don't have stage2.bin anymore. We have stage2.elf. Do we have stage2.bin anywhere else? No. Okay. And now this should work. Okay. And let's put a breakpoint in start. Let's try that. Function start not defined. Does it have let's check the stage2 map file. Okay, so it does have a start symbol. I wonder if okay, let's just put a breakpoint at where we expect stage2 to start. So let's put a breakpoint at 1000 and continue. Okay, and we have reached this breakpoint. Let's show the assembly code. Now we should be inside this little entry code here, which jumps to protected mode, basically. And finally, after jumping to protected mode, it should call this start function. Okay, so there's start. Let's see what address start has and put a breakpoint there. 1, 2, 3, 5. Okay, the issue I think I might be having, the question is, do I have debug symbols enabled? Because I might not have. Let me check. And we don't have debug symbols here. I don't think we have debug symbols. Okay, let me see In the kernel, do I have any? Okay. I think it should be fine. I think we should still have debug symbols. Let me do one more thing here to check. Okay, now that we have stage2.elf, let's use readelf. And see what... Okay, so we do have debug symbols. Here they are. These are all the debug symbols. And we should theoretically have one that is called start. Yep, this is right here. So in theory, this should work. If I put break start... Okay, it hasn't worked. I don't know why. What if I put like a function, like some other function? Okay, let me check one more time. So we are setting these two symbol files. Do we need to set them later, maybe? Okay, let's try to set them later after starting the... Okay, but I want to do const debug. Okay. It's still fine. Okay, it's not finding the start function. Okay, let's see if we can list the symbols it can find. Okay. Maybe we need to put the source file as well. Let's try that. So that one would be main.cpp start. Okay, doesn't like that. No. No symbol. It's not working. I don't know why exactly. Okay, I'm gonna try. I'm gonna try one more thing. Let's see if I go to stage2.map and I take the start location from here. So it's 1, 2, 3, 5. Let's try to put a breakpoint at 1, 2, 3, 5 and continue. It's not finding the symbols. I don't understand why. I think I know. I think I have an idea why, but what if it's this target thingy? What if I have to comment it Let's try like that. It's not finding the symbol. I don't know why it's not working. If we use readelf again to read stage2.elf, and we look for start, then it is at address 1235. I don't know what's wrong. I honestly don't know what's wrong. Maybe... Is the path correct? Okay, so it's build i686 debug, stage2, stage2.elf. Yo, what are you doing? I don't get it. Why GDB is not finding it? Doesn't seem to be this. I mean, I'm not really sure. Multiple symbol files. It should be fine. It shouldn't have any problem with that. Let's try the comment. Let's try that way. Okay. Oh. You are correct. Thank you, Peter. So it doesn't work. If I continue. You're a genius. I didn't expect it to not work. I was hoping it works, but apparently, yeah, apparently it doesn't. And now we have full debugging symbols, and we can actually see the source code, we can see the variables, and this is awesome. Debug file directory. But I have multiple directories, so I don't know. Can we print, for example, boot drive? Yes. Partition. Magic. It works. It's great. All right. That's something else. Yeah, so apparently to debug the kernel and the stage2, we need to set the different symbol files. What I think I'm going to do is I'm going to duplicate inside the scripts folder that I have here, I'm going to duplicate this file. So let's create 2 copies. Paste. Okay, so the first one is going to be debug stage 1, where we know that I'm not sure if this is even necessary. Hold on a second. Let me try something. Let me try it like this and see if it works. I'm not seeing any problems. I'm not sure if there are... Okay, but if I go to assembly, does this look correct? I think it might. Yep, this looks fine. Okay, so I'm gonna leave just 2 versions. I'm not gonna have 3. So let's have this one be called debug stage 2. And here we're gonna set the symbols for stage 2. And I'm gonna leave this in. And this one is gonna be for kernel. And that's it. Okay. And I think we can leave this. I think I'm not going to leave this in for the kernel, because in the kernel we don't actually need 16-bit code. We don't need any 16-bit stuff. So we should be fine there. Okay. One more thing here in... okay, so I have this debug command as a phony target. And I'm gonna add another debug underscore stage2. Debug. Let's keep the names consistent. So debug underscore stage2 as well here. Okay, and then I'm gonna add this depends. Okay, looking good. There's one more thing that I want to do before finishing this live stream. Hold on, I had a commit somewhere. I have it somewhere. I'm trying to find it. Okay, I remembered. So instead of defaulting to the image, I'm thinking of defaulting to building like the kernel and stage 1 and stage 2, and only building the kernel when typing sconce image. Would that be okay with you? What I'm thinking is, because maybe you don't want to have it ask for a sudo password every time you build. Maybe you just want to build, make sure that you have no compilation errors, and then finally you want to create the image. Or maybe you have some tests, or maybe you have some other stuff that doesn't require being on the image. And that's why I'm thinking of changing this. So what I need to do to achieve that is to basically in each one of these script files, I am exporting a variable for stage 1, stage 2, and kernel. And then I can just import them whenever I need them. And here, instead of defaulting to image, I'm going to default to stage 1, stage 2, and kernel. And for the image, let's create an alias that says image and points to our image. Okay. So now when we run sconce, it... What? I think your object is not callable. Do I need to use like an environment for this? I don't remember. Let me check. Okay, so what is the problem here? Module object is not callable. What module object? Let me check it. Okay, alias targets. Okay, I remember. So instead of pointing to the actual target, you are pointing to a file. So that's why it wasn't working. So we need to do image.node maybe. Not node, destination node. What was it called? Okay, so this is a target. What do targets have? I forgot. Let's just do dir of image. I don't remember what it was called. I'm sorry. Print. Okay, so this is the list of all the stuff that it has. And I am looking for is... I don't see it. Hold on, let me... Wait, this is a list. Do I need to do image of 0? Hello? Module object is not callable. Okay. I'll just try to find it. I fixed it at some point. I don't remember how. I'm sorry. I honestly cannot find it. I don't remember what I did. Okay, yeah, that's what I did. So apparently the problem is not this. The problem is that alias is not in the default namespace, so I have to use one of these environments to call it. So environment.alias and then image. Sorry. Okay, yes, it looks good. So now if I type in scones image, it's gonna build the image. Image is up to date. Great! Yay, okay. I'm going to commit all these changes, and then if you have any more questions, I am listening because I am about to finish this live stream. Okay, so let's call this implemented. Okay. Bug. Okay, commit and yeah, I don't want this one. Everything else but that one. Okay, there was that question about how to... Yes, yes, I remember. Yes, okay, I will show that. Okay. Commit and push. Yay. All right. Okay, how can I show this? Because I already have everything set up on my system. I kind of need a clean machine. I don't know if I have any. Okay, I'm gonna try to do it with Docker. It's not fun, but let's try anyway. I'm just gonna run an Ubuntu image and okay, the -it was after. Do I even have Docker installed? Oh no, I don't have Docker installed. Okay, I'm gonna run this on my server. Okay, so right now I am inside a Ubuntu image basically, and I'm gonna install I'm gonna show all the steps. Okay, so first things first, let's go get the source code and see what dependencies we have. Okay, so this is a Ubuntu image, so I'm just gonna install all these tools. I'm not gonna install Camo because that one is kind of big. I'm just gonna install all the others. Sim. Okay, I'm thinking how to do this. Because libguestfs won't work inside the Docker. I really need a virtual machine. Let me see if I can find. I have VirtualBox, yay. And I will need. I don't know if I have a Ubuntu downloaded or some other distro. Let me check. Okay, I'm done with this. I'm done with this. Okay, I need to download the live CD of some distro. Let's just get something. I don't know. I think Fedora is pretty large, so let's get something lightweight. I'm gonna get Xubuntu. Okay. Download, where are you? Okay, so I'm currently downloading Xubuntu, and I'm gonna create a little VM so I can show you. Do I have enough space? Because I always have problems with that. I have, okay, 100 gig is available. That should be enough. Okay, let's answer more questions while the thing is downloading. Okay, here is the progress bar. Okay. Okay, question. Can I use a font from a hard disk to display a character? I'm interested in loading the font. Not yet. In order to render fonts, you need graphics. You need to do graphics. I am planning on doing graphics at some point in the future, in maybe a few... there's a few videos that I still want to make. I still want to cover, to finish all the memory management stuff. There's the, virtualization stuff that I have to cover. And I'm also thinking about maybe covering some file system stuff. And then I'm going to discuss about graphics. It's fun. It's really interesting. And it's something that really fun to do. If you already have graphics, then yes, you can load a font. Something that I would recommend trying, because you may not have, is to use a third-party library. So there's font 8x8. It's one that I actually tried to use before. This is basically a font that you just include. You just take this font 8x8, you include, actually you don't even need the whole thing, you just need like the basic. You include this into your operating system, and this is basically a bitmap. It's 8x8, so there are 1, 2, 3, 4, 5, 6, 7, 8 bytes for each character, and each byte is going to be like a line, a scan line. And all you have to do is simply put a 1 or a 0. So you put like, I don't know, white or black or whatever color you want. Rendering this is really easy. So yeah, if you already have graphics, if you are already in a graphics mode, this is the easiest way of getting text to the screen. The next thing is, yeah, you probably, in the long term, you probably want to load it from disk. And for example, you can use the Linux font system. Linux has some fonts. They're called, I don't remember how they're called, Linux terminal fonts. No, it's not these. They are fonts used in... okay, text fonts maybe. How are they called? Okay, the TTY font, that's the one. That's the one you're interested in. Console fonts. So Linux has these console fonts. And there's some command in Linux that you can use to change the font. And this one has a not so complicated format that you can actually parse. Yeah, so they are in these PSFU format. I'm not sure. Okay, PC screen font. There we go. There we go. There's an OS Dev article on it. So apparently there are multiple versions of this. Some might be easier to parse than others. And this is basically the format that you can use. This is probably the easier way of getting fonts. The more difficult way is to port a text rendering library like FreeType. FreeType is essentially a library that's used extensively in a lot of projects to render fonts, like all the fonts that you have in your Windows system, for example. It's used extensively. I think it's also used by Linux itself. But yeah, porting this library is probably not as easy. It's the more difficult thing to do. The cool thing is it doesn't rely on any kind of backend like, I don't know, OpenGL or something like that. It's just going to render it to an image, a texture in memory, and then you can do whatever you want with that texture. It's used by many. Game engines. It's used by, as I said, I think Linux itself uses FreeType, and I think it's not the only one. I think there are alternatives to this. You can try. Yeah, Rust type, a pure. There's all kind of lightweight alternatives, so it's not the only one, but it's the most used one. Okay, you checked part. So I checked out. Okay, I'm gonna show this. Why not? Okay, Ubuntu is finished. I'm gonna do that now. VirtualBox, let's give it. Ubuntu. All right, this is fine. Username and password. Can I skip this? Skip unattended installation because I just want the live CD. 8 gigs of RAM should be okay. Let's give it more processors. 4. Okay. finish. All right. Questions. Yes, let's see the questions until this boots. Okay, so I checked out part 7 and I did make toolchain, but scones doesn't. Okay, so scones is not working for you. Okay, we'll check it out. Okay, we'll try it in this VM and make sure it works. Quick questions. I would like to make my bootloader more general purpose, so I would like to be able to load stage 2 from different file systems. The way I approach this issue with multiple file systems is to not try to parse any file system inside stage 1. That's the biggest mistake. And that's kind of the thing that I did at the beginning. Parsing file systems in such a limited space is difficult. So what I have done for even today, what I've done today is essentially stage 1 is really dumb. It doesn't know how to load anything. It needs to be told what to do. And it is told what to do using that structure, boot table structure that I created. And that's essentially how it works. So that's how you can make it general purpose. Yeah, so instead of trying to and yeah, another thing is it's gonna be a lot easier if you don't put stage 2 inside the file system. It's easier to have it, like as you've seen here, as part of the reserved sections, as part of the reserved sectors. That's how I did it for the floppy disks, or as part as you know, in the space in between partitions. These are your two options. And this is how grub works. It uses the space in between the partitions. Okay. Bit loading. Okay. Yeah, and that's exactly what I said. So don't try to load stage 2 from a file system, because it's going to be difficult and you're going to have a lot of problems with it. Try to put stage 2 outside the file system so it's easy to find it, and then or use the reserved sections, reserved sectors if you have those. Yeah. Okay. Are we going to use PSF fonts? I don't know yet. I was explaining how to use PSF. Okay, I was explaining how you can get fonts for your terminal and how you can load them. Maybe, I don't know. It depends. I don't know yet. This is the far away in the future thing. You want to offer me a job? Okay, we'll discuss in Discord. If I'm planning a video on how to make UEFI bootloader, yes I am. Yes I am. The thing is, right now I am focusing on getting the kernel done, and I'm gonna do more bootloader development later. Getting to 64-bit is my #1 priority right now. And of course, as part of that, you kind of have to explain virtualization and memory virtualization to do that. And that's why I haven't done it yet. That's my biggest... but yeah, I am planning to do EFI in the future. Okay. So you want to restart it. Why is it looking like this? Why is it so small? That's odd. Display. Okay, scale. Let's do 1 point. Okay, and Full HD. There we go. What the hell is this? Some driver issue probably. Whatever. Okay, let's try to make it work like this. I'm just gonna make the text bigger. I don't know what's wrong with it. And I honestly don't care. Okay, so let's start by going here and installing all our dependencies. This is Ubuntu, so I'm just gonna copy these commands. Okay, let me go to the C. Okay, I'm not gonna do the C++ branch. I'm gonna do this branch. Yeah, it is fine. And this is gonna take a while until it installs everything. What I see that is missing from here. Okay, so I was installing the Python stuff from requirements.txt. Let's see if it's complete. Maybe I missed something. Okay, scones is not here, so you need to install scones as well. That's my bad. Okay, so I do have scones. Was it in those build utils? Python 3 parted scones. There it is. So there's scones. So we have scones. Great. Okay, now let's copy this source code. I don't have Git. And now git clone. All right, and now we want to build a toolchain. For the toolchain, I had a bug. Okay, so it cannot find sh because I haven't installed it. So let's do sudo pip 3 install sh. Okay, and what else are we missing? So we are missing the toolchains directory. That's the error. This is actually something I fixed today in the C++ branch. There are two ways we can fix this. If you can either create a directory here outside where you checked out the source code. So toolchains. And then let's run scones toolchain. The other way is to simply edit. Let me show you. Okay, expected an absolute directory name. This is another bug that I had and I already fixed in, I think, in the C++ branch. I don't remember. I remember fixing this at some point. Okay, so in config.py, you can change the toolchain directory here. So you can put it to whatever you want. The thing is, it has to exist. If it doesn't exist, it's gonna give that error. Let's fix the other issue as well. So set up toolchain. The problem is here. Okay, so the configure script is expecting an absolute directory name, and we didn't give it one. So the way I fix this is by doing real path of this. This is how I fixed it. I think there's a commit somewhere where I have this fix. I don't remember. Okay, and we can also fix the other issue that with the missing directory by doing mkdir -p and then this toolchains dir. Okay, that should fix the problems. Okay, and now this is gonna take quite a while. This is gonna take a while. Okay, let's see if there are any more questions. This build is gonna take a while because I've only given it 4 cores, so it's gonna take a while, maybe 10 or 15 minutes. Okay. Okay, no more questions. Should we wait until this finishes? Because it's gonna take a while. Yeah, no problem. Okay, I'm just gonna wait for this to finish, and I'm gonna let you... I'm gonna get back. In fact, you know what? I'm gonna be right back. I'm gonna take a short break. Good EFI libraries for assembly with some docs. I haven't really researched it, so I don't know. No space left on device. You know what the problem is. I'm inside a VM, so I'm in a live environment. So I need to move this to the actual file system. And I don't even have partition manager. Let's create a partition. It doesn't matter. MS-DOS is fine. Next for partition. Because this is running in memory. That's the problem. This partition that... This temporary partition that the live CD created is basically in memory. Okay. chmod 777 that media. Okay. That was fast. I did not expect it to go that fast. And let's also move that tool change directory. In fact, I can delete it. Okay, now let's go to that weird drive and sconce toolchain. Okay, now this is gonna take a while, unfortunately. Okay. Yeah, it's a live environment. I gave it 4 gigs of memory, right? Okay, that's gonna take a while to build. I'm gonna be back in 5 minutes, okay? Taking a short 5-minute break. Let's... And I'll be right back, okay. And I'll answer any more questions if you have any, okay? So I'll be right back. I'm back. Okay, what's going on here? Why is this taking so long? It's out of memory, I think. I should have gave it more. It's unresponsive now. Okay. Happy thoughts, happy thoughts. Can we change it live? I think in VMware I can do that. Not sure if VirtualBox allows me. No, I cannot change anything. I think I'm gonna kill it and I'm gonna restart this with more memory. Like, I don't know, 16 gigs or something. Okay. I hope this won't affect the stream. Oh, okay, it shouldn't. I have for 48 gigs. That should be fine. Alright, so processor, let's give it more. Let's give it... I can give it up to 12, so let's give it, I don't know, 8. Hopefully this will work. Oh no, and it wasn't live installed, so now I have to reinstall all the dependencies. That's okay. How do I suggest to learn about making compilers? Let me think. I think the best option would be to take a course, like a university course about compilers. You're gonna learn a lot more than just tutorials. There are really good courses out there. I also learned about it in university, and it was useful. It was interesting. So yeah, I would say to try to take up a course. Maybe MIT has something, or I don't know. There are plenty of online sources available. Okay, so I need to reinstall the dependencies. Oh, you're learning from source code. That's also an option, but I don't know. I think you should take up some compiler design course. GCC maybe isn't the best compiler out there. I don't know. Okay, so now we should be able to run scon's toolchain. Oh, okay. So forgot about the Python dependencies. pip3 install sh, and that's it. And now we wait, and hopefully it doesn't hang this time. Yeah, LLVM is a nicely designed compiler. Yeah, you can learn a lot from it. And I think you can also learn a lot from other compilers, like the Microsoft .NET compiler. It's really good. It's very well made. And others as well. Sure, why not? I agree. GCC, and this kind of applies to a lot of GNU code. A lot of code from GNU is kind of messy. Yeah. And it kind of applies to a lot of projects from GNU. But yeah, the best option to learn is to probably take up a course. That's what I would recommend. I'm sure that there are very good courses on compiler design, and yeah, you also need to learn about the EBNF, or however it was called, that language that... But yeah, it's interesting. It's a lot of stuff that you can learn. Yeah, any other questions? I kind of running out of things to say. What am I gonna do after memory management? Yeah, I'm gonna do 64-bit. That's definitely something I want to do immediately. And then I'm still thinking. I'm between... There are basically like 3 or 4 main topics that I want to cover. One of them is multitasking, obviously. User mode and everything else. The other would be the, file system stuff, virtual file system and all that. The third would be hardware detection, and that's a huge topic. Hardware detection, drivers and all that. Driver model, and it's quite a lot in this area, and I haven't even started there. I kind of wanted to do things right, which is why I haven't started implementing any... Is the build actually done that fast? Wow, I'm impressed. Let's see if we can actually compile now. Yep, it works. It works. Okay, we're having some issues with guestfs, guest mount. So what is the error? Because I don't get it. Okay, so there's something related to guestfs. As you can see, it doesn't work always, and I've had trouble with it myself in WSL. So I think the things that I did today in the beginning of the live stream about adding support for mount is gonna solve your problem if you have any problem with this. Yeah, so I was talking about the main topics that I want to cover. So the last one is graphics, obviously. So there's that. I haven't decided exactly which one to start with, but it's gonna be one of these 4. I'm kind of tending to lean towards hardware detection. Or maybe... No, I'm gonna do file systems first, because that's the most useful and something that a lot of people are gonna want to have. And then I'm gonna probably go to hardware detection and then graphics, or maybe graphics first. I don't know. I will see. Thoughts on UEFI? I've already mentioned I am planning on adding support for UEFI at some point in the future. I don't know when. It's on my to-do list. It's in my backlog. Maybe I'll put it to a vote to see which one is more higher priority and which one to focus on next. I don't know. Okay, so that's... UEFI is fine. It's a new technology. It's supported on some ARM architectures as well, which is very cool. And I think RISC-V also, I'm not sure. Yeah, it's great. It's the future, I guess. What can I say? The thing is, I kind of have a thing for retro machines, and this is kind of one of the reasons why I started with legacy mode. What I'm dreaming of is maybe one day I'll be able to use this operating system that I'm building to actually do something useful, to have like a bootloader that can boot, that can basically hide partitions and show partitions. That's one thing that I was thinking of making. So I have this really old Pentium 2 computer, and I kind of want to play around with it a bit. I want to play with old versions of Windows, of maybe even as old as DOS. Maybe trying out OS2, maybe trying out some older distros of Linux. And the problem is that right now, the way I can do that is through a... by basically taking out the hard drive and putting it into my current computer and trying to change the hard drive configuration to be whatever I want. And that's a bit annoying, because I cannot basically save the multiple versions. And that was what I was thinking. Maybe I can use a single hard drive and have multiple partitions, but have this tool that can hide partitions, so you will be presented with like a nice boot menu that you can pick whatever operating system you want to load, and then it's gonna hide all the partitions that are not relevant to that operating system, and that is gonna boot it. That's what I was thinking. Maybe I can use this for that. I've also gotten another machine recently. Hold on, just a second. Okay, so I got this old laptop, which has basically a Pentium 4 processor in it, and it's fun. I mean, I kind of like I like having fun with these. I don't know if it works yet. I haven't tested it. It's a Latitude. I don't know. Let's see. Okay, it's written right here. So it's a Latitude C540. That's the model number. I don't know if it works yet. I found it really cheaply for like, what was it, $10, something like that, $10 at the like one of these markets with old stuff. And I'm still searching for a charger. I found one, I ordered it. It was really cheap as well, like $5, and I'm waiting for that to arrive, and hopefully it works. We'll see, I guess. But yeah, I think it's fun having, you know, these old machines are fun. I enjoy working with them. I even set up like a hard drive with somewhere around like 100 old games installed to it. Yeah, I think it's very fun. I think old machines are very interesting because it was a different time. It was a different time when things were simpler and operating systems were simpler. You didn't have that many, I don't know, stuff going on in the background and all that. Yeah. Pre-existing to like Ventoy. The problem is that Ventoy won't boot properly very old stuff like MS-DOS. MS-DOS is very tricky to get working. As far as I know, MS-DOS may not even support partitions, disks larger than 8 gigabytes. So getting these working is a bit of a challenge. I'm also considering getting like one of these SD card adapters and just using SD cards. It's a lot easier than trying to make a bootloader. Okay, so I recently thought of implementing elf parsing in user space. What do you think? Yeah, that's great. So the init file would be a binary file, and that would ensure a parser is loaded for elf. Okay. Nano kernel. I don't understand what you're trying to do. I'm sorry. Yeah, that's okay. Yeah, I think I'm gonna finish for today. If there are no more questions, thank you a lot for joining me, and see you soon. I think I'll make another live stream maybe tomorrow or 2 days after tomorrow. I have a few days off and I can work more on this. I really want to get that C++ migration finished. Yeah, thank you for joining me, and I guess I'll see you soon. Bye.